Hi, I'm Tyler Bull with Frontier Precision. In this video we're going to be covering generating a known position on a predetermined projection like state plane using an RTX survey style, and then using that known position to set up a static survey for our base that will collect data that we'll then use for post-processing a mobile mapping run. So to start with, we're going to want to check out our survey styles and get those set up. Our survey styles are like templates that dictate what our receiver is going to be doing, what kind of data it's going to collect, and how it's going to collect it. So in order to do that, we're going to first hit this menu bar here, scroll down to Settings, Survey Styles, and the only two that we're going to be worried about in this video are the Fast Static and the RTX survey styles. So since we're going to be using RTX first, we'll set that one up first. So we'll click on that. And RTX, there is no base station sending corrections. You're getting all your corrections in real time from the satellite constellations that you can see. So all we have for options are rover options, survey type RTK, that's real-time kinematic. Broadcast format's going to be RTX. The antenna type, in this case, I'm going to be using an R980 receiver. You might be using something like an R10, so you would just change that here to the R10 internal. For the measured to option, so this is just going to adjust your antenna height to correct your elevation based on what you select for what you measured to. In this case, I have a lever extension on my setup, so I'll be measuring to the arm of the lever extension. So all I have to do is select this, and then when I input that measurement, it'll automatically correct it to the center of antenna. For this, I want to leave my tilt functions turned off. That's just personal preference. Here you have all of your constellations turned on. Go ahead and hit accept. And then the only other thing I'm going to edit in here is my topo point. And what I want it to do is auto store the point. Go ahead and store that. So now we'll move on to the fast static survey style. And for this one, it's going to be the opposite of RTX. All we care about are the base options for this one, since it's going to be set up as a static base station collecting data. So right up top here, we want to make sure we select fast static for our survey type. You want to make sure you have your antenna set to the correct receiver. In my case, it's going to be the R980. Measure to, we want to change that to the R980 lever extension. For our logging device and logging interval, the device is going to be the receiver. We don't want to use the controller because we might be moving away from the receiver with the controller. So we want it to log all that data into the receiver for us to be able to download later. And as far as an interval, we'll just set that to 1 second. So that'll upload a data packet into the receiver every second from the satellites that it's receiving corrections from. Go ahead and accept. And we will store that and escape. So now our survey styles are good to go. We'll go along to setting up a new project in Trimble Access. So right here, this is the home screen for Access. All of these projects are basically just folders that house all of our job data, like our actual job files that we'll be collecting data in, any reference files like PDFs or CSVs. So I'll hit new here, and for this project I'll just call it Vantage Point. None of this other information is necessary. You can fill in these boxes however you choose. So we're going to be working in state plane. And so we're going to have to change our coordinate system to reflect the state plane state and zone that we're in. You'll have to reference a map that shows the locations of those state plane zones to know which zone you're going to be working in. But to start, we'll give this a name. Template, I'm going to select US survey feet, and that's just going to affect what units we're using. There's international feet and US survey feet, which are slightly different, and then metric. For coordinate system, we're going to select this box here and click on select from library. So right here you'll see a few drop downs. This first one is the system, United States NAD 83. This one will never change as long as you're working in state plane. The only thing you'll have to change is the zone that you're working in. So in the case of this example, this video, I'm working in North Dakota South Zone. So I will select that. Use geoid model, yes. We'll always use geoid 18. It's the most current geoid model for elevation. Coordinates, we'll stick with grid. Project height, you want to be around a few hundred feet of where you're going to be working. In my case, I'm 1,500 feet above the geoid. So all this information here looks good. We'll go ahead and store. And now I shouldn't have to touch anything else in here. The rest of this information should be good to go for us. So I'll hit accept. So now our job is set up. It's zoomed in on our project area. If you have one of the newer versions of Trimble Access, you'll have these Trimble background maps by default. In order to turn those on and off, we'll come over to this left toolbar, go to the Layer Manager, Map Files, and then Trimble Maps will be right here at the bottom. There's a few different options that you can select from. So, starting up our survey, what we're going to want to do is go into the menu bar here at the top left, go down to Instrument, GNSS Functions, and first we need to connect to our receiver via Bluetooth. So we've got two options here. We've got the rover, which we'll be using to survey in RTX, and the base that we'll be using as our fast static survey to collect raw data. So I'm going to start out with my rover. I've already connected to this rover before, so it shows up right here with the type and the serial number. The serial number is just on a little sticker right on the bottom side of the rover. If you just flip it over, you can read that. If you have multiple rovers in here, that's how you can identify between those. If you're connected to it for the first time, you'll go down here and select search, and a list of discoverable devices will pop up over here. But I'm going to be starting out taking a measurement in RTX, so I'm going to leave this as my rover for now. And I have rover mode selected, so I'm going to go ahead and hit Start Survey, RTX. Okay, so now we're connected, and my receiver is receiving corrections. You can see my residuals right here. I've got 8/100ths by 2/10ths of a foot, which is pretty good for RTX. All I need to do here is enter my antenna height, and that's to the bottom of my lever extension. Okay, so now my survey is going. I'm viewing 22 satellites, getting good residuals. I'm going to go ahead and take my initial measurement that I'm going to use as my base point for the next survey style. So click measure at the bottom here. I'm just going to call this point 1. Code, this is just an arbitrary name. You can give your point, I'm just going to call it base. We'll do a 2-second topo point. Again, you can adjust your antenna height here. And then I will go to measure.
Observation stored.
and you can see that we got the notification that it stored that observation. You can view that point on the map screen here. So now we have a base point for our fast static survey. So switching over to that, we'll go back to menu, instrument, GNSS functions. We're going to end our roving RTX survey. We'll leave the receiver powered up. And then in our Bluetooth settings, we have to change our rover to none or to a different receiver, it doesn't matter, and switch our base over to the rover that we're going to be using now as a base station instead of a rover. Once we've done that, we'll then select base mode. It's going to reconnect to that receiver via Bluetooth. Start survey, and this time we'll be using fast static. And so now it's going to prompt us for a point name for the base. Since we're set up on a known point, which was 1, we'll use that. You see it fills in that code automatically, it recognizes that point. For antenna height, once again, to the lever of the R980 extension, if you're using an R10, this will say R10 extension, it's the same thing. And then we'll select start.
Waiting for satellites.
Base started, and so that's all that is to it. We're now collecting static data from our base station. In order to double check this, you would just look at the faceplate of the receiver. In the bottom left corner, there's a little arrow pointing down. That should be lit up, and that basically means that you are logging data. Alright, so now some time has passed. We're done with our mobile mapping run or our drone flight, whichever one it may be. We're ready to end our static survey and pull the data off the receiver so that we can post-process our mission. So what we're going to do is hit the menu bar, instrument, GNSS functions. We'll select end survey and end our fast static survey. Power down receiver, no, because we're going to upload or import the files from the static session that we just performed. So while we're in GNSS functions, we'll go to import files and we'll look for today's date, which is the 10th. You can see I've got a TO4 file right here. So I will import that. Transferred successfully, so now that TO4 file transferred from the receiver to the data collector. It'll just be in this project folder once you navigate to your Trimble data folder in the collector. To find your TO4 file after you've imported it from the receiver, you're going to want to navigate to your program data, Trimble. Your data collector device name will be right here in place of this. I was using my emulator for this demonstration. Trimble data, projects, and then you'll go into the project folder of the project you were working on. And then when you created that job file, it created a folder for files associated with that job, and that's where it sticks that TO4 file. You can see that right here, and you can copy that over and convert it to Rhinex so that you can use it for post-processing your mission in TBC.